So I want to calculate the area under y equals x squared. Well, let's say I want to calculate from 1 to 2. Y equals x squared will look like this. And let's say this is the one, I'm going to exaggerate the spacing between them. This is the 2. So I want to calculate the area between them. So one way to do it is you take this and cut it into pieces. So let's say I decide to cut this into 4 pieces, equal space between them. That means if this is 1, this is 0.25, this is 1, maybe 5 pieces, huh? Let's do this. That's I can't write small. We have 4 or 5 pieces here. Where's my eraser? I should write sideways so you can fit everything there. So if this is the 1, and if the space is the same between them, this is 0.25, this is 0.5, this is 0.75, and that's the 2. 1.25, right? 1.1, 1.75, and the 2.0. Let me write everything sideways. Now, one way to calculate that is called the lower sum, which means when you get to each one of these, to calculate that, we use the lower height of the 2. So when I calculate this area, I'm going to have that area, that sum. And for this, I'm going to have this one. And for this, you're going to have that. And for the last one, you're going to have this. You can see we missed a lot of spots. Can you see what we missed from each one? Where's my pink marker? It looks like I missed all of this here. Does that pink show up there? Yeah. And I missed this one, this little triangle, almost triangle. And I missed that piece. And I missed that piece. The more cuts I put there, the less I'm going to miss, the closer I'll get to the answer. That's known as the lower sum. So if I use lower s there, that's the lower sum. Let me just make sure our book uses lower and upper sum. Yep. So they were called s, lower s. So to find that, I need to know what the height of this. Well, the height of this is it's the y value when x equals to 1. When x equals to 1, what's 1 squared? Which is 1. That would be 1 times the gap here. What's the width of that? 0.25. Plus. Let's look at the second piece. That's this one. Well, what's the height? Isn't that the y value when x equals what? 1.25? So this is f of 1.25. So what is 1.25 squared? When you square that, it's 1.5625 times the 0.25, the width. The next one, what is the y value here? That's x equals 1.5. That's f of 1.5. So go to this one. What's 1.5 squared? It's 2.25 times the width, which is 0.25. And the last one is this height, which is the y value when x equals 1.75. What is 1.75 squared? That's 3.0625 times 0.25. So the lower sum, lower s, small s, You multiply these numbers and add them. 0.25 plus 1.5625 times 0.25 plus 2.25 times 0.25 plus 3.0625 times 0.25 equals, and the answer is 1.96875. So if I approximate the area by using the lower sum, that's what I'm going to have for an answer. Now, what about if I decide to use the upper sum instead of the lower sum? Again, let me graph this. I'm exaggerating here. This is the 1. This is the 2. 1.0, 2.0. I'm going to break it down again, the same number here, and see what the upper sum will give me. This is 1.25. This is 1.5. This is 1.75. For the upper sum, we use the bigger height, the larger, not the smaller. So for this, we use this height. And you can see now, I got extra in it. For the next one, we use this height. For the next one, we use this height. And for the next one, we use this height. So this has, the first one was missing pieces, this one is adding pieces to it. So let me find the height here. The height, that's the y value when x equals 1.25. The height here, the y value when x equals what? 1.5? The height here when x equals what? 1.75. And the height for the last one, that's when x equals what? 2.0. You got to use that height. So what is the sum? We use capital S for the upper sum. For this piece, the height is going to be 1.25 squared, which is 1.5625 times 0.25. For this, I got to use the 1.5, the height. So what is 1.5 when you square it? 2.25 times 0.25. For the next one, the height is what? F 1.75. So take the 1.75 and you square it. And for the last one, the height is going to be the y value when x is 2. When x is 2, that's 4 times 0.25. So let's see what that is going to give me. And this gave me an answer of 2.71875. I pushed the right button. I know this is too big. I know that's too small. How would I know that? You can see this is missing all the pieces. You can see this one has all these extra pieces in it. See the extra pieces? So if you want to be kind of fair to your answer, neither one is right. This is less, this is more. What do you think a fair way will be? Average them. So if you average them, if you take the lower and the upper and add them, and you divide by 2, you should be in the neighborhood. So if I average these, that'll be approximately what the area is. The more I cut there, and I'll show you why, the more I cut will be a better result. For homework, you get like two or three problems with these, and they'll tell you how many cuts to use, because they're not going to spend hours on it.
Are you always going to have to do lower and then upper?
Well, if you want to get a good result. Now, there's another.
I mean in that order.
For homework, they'll ask you for both. They'll say what.
Should you do lower before you do
No,
upper always?
no. They can ask you for the upper first, then the lower. Yeah. They'll ask you two different questions. What's the lower sum? What's the upper sum? 34375. That's the average, approximately. Really. Now, there's some people said, why not treat this as trapezoid? You know what a trapezoid is? You connect these points with a straight line. And there is actually a method like that. It's called Trapezoid Method. Our book doesn't discuss that. Instead of doing lower and upper sum, we connect the 2 points here with a straight line, and we calculate the area of each trapezoid. When you have a shape that looks like that, just heads up for those people who want to do it, if you have a shape that looks like this, that's known as a trapezoid. If I call this distance the height, if I call this one A1, I call this A2, or I call this the base, whatever you want to call it, it's actually the area of that. It's 1/2 add A1 to A2, then multiply it by H.
Or B or whatever that is.
Oh yeah, I use B. Yeah, thank you. So you might see that written as A1 plus A2 times B divided by 2. The reason, anyone knows why that answer is that? If you cut it into two triangles, this is the first triangle. You can cut it any way you want to. There's one triangle, and there's a top. What's the area of this triangle? Isn't it base times height divided by 2? So the area of this triangle, the first one, base times A1 divided by 2. Add to it the area of this triangle, which is the base. If I use this the base and this is the height, B times A2 divided by 2. And if you put them together, you can factor a B out and you have A1 plus A2. That's why the area of a trapezoid is A1 plus A2 times the base divided by 2. Because it's two triangles and you find the area of each one, you add them. Now, I wanted to show you something, actually, if I enlarge that picture, because I'm not going to spend a lot of time on Riemann sum doing these examples. That's just a silly way of doing it, but let me zoom in on one. Let's say I take one of the boxes, just one of those boxes, and I'm going to use that space between them. And regardless if I use the lower sum or the upper sum, let's say I'm using the lower sum. If I use the lower sum, I am losing all of this triangle on the top, right? But watch what will happen if I cut it into two cuts instead of just one now. So the area right now is this piece. I'm missing this whole triangle. What happens if I cut it one more cut? Well, for this box, it doesn't change anything. But for the box, this one, I'm using the lower height, so I'm going to use this height, and now I'm gaining that piece. And what happens if I cut it twice that number? So for this doesn't change, but now for this, I'm going to gain that little piece. And for the second one, I'm going to gain this piece. So I'm using less. And every time you cut, more cuts, more cuts, more cuts, you'll gain more and more and more till eventually you have really the area under that. But to get the area under that, how many cuts you need to cut it to? Infinite. Close to that number. Well, nobody's going to do infinite cuts. Nobody in the right mind. So how do we find the area? That's where integration comes in. So we're going to be talking about something called definite integrals. One of the applications for integration, remember when I did this, I cut it into only 4 or 5 pieces. I came up with that number. I'm going to do it the correct way and show you what the exact answer is. The exact answer, if you want it, let's say I want to find it from 1 to 2. I want to find that area again. This is the 1. This is the 2. I want to find this area without using Riemann sum. One of the ways of doing it is by integrating that. This is y equals x squared. So the area will be the integral from 1 to 2 of x squared dx. That's called definite integral. Why? Because we've given you the lower limit and the upper limit. All the ones we did in the past, none of them have limits in them. From last class, last video, all the ones we did were indefinite integral, no limits. So let's treat this as indefinite integral. Remember the rule for integration? What do? You add 1 to the power and you divide by the new power. So if I add 1 to the power, that becomes what? X to the third over 3, and you always add what? C. And you want to calculate that as x goes from where? X equals to 1 to x equals 2. And the way you calculate that is you take the value of this at the upper limit, the 2, minus the value of this at the 1. You're going to see something neat about them in a minute there. You're going to find out when you have definite integral, you do not need to write the c there. It's going to cancel out every single time. So anytime you have a definite integral, you never put the c because it's just a waste of your time. But let's leave it for now. When x is 2, what is 2 cubed? 8 divided by 3 plus c. Minus, now let's find the value when x is 1. What's 1 cubed? 1/3 plus c. And what do you notice about the c's? They will cancel each other out. You will have 8 over 3 plus c minus 1 over 3 plus c. This becomes a minus c because the minus sign in the front changes all the signs. Notice the c's, they will cancel. What is 8/3 minus 1/3? Is that 7 over 3? Let me divide 7 over 3 and I'll get what? 2.33333. And that's actually the actual area. When I approximated that by using this method, I only did few cuts. Look at my answer. 2.34, they tell me 2.33. I bet you if I cut one more cut in these, I'll have 2.33 and some other numbers. I did this just to show you that it really, the integral, when you have a definite integral, you're finding the area under that curve between this and the x-axis as x goes from 1 to 2. That's what you're finding.
So that's the exact area?
That's the exact area, correct. That's not the approximation. This is the approximation. That's the exact. But if they ask you to write an exact answer on the software, you got to write what? 7/3, yes. Oh no, it wouldn't. If you put a lot of 3's, we'll make it wrong, because that's an approximation. Never, it doesn't have an end to it. I seen it. He goes, try again.
Yeah, even if it's like.
Even if you put 10 3's here, they'll mark it wrong when they say exact answer. So let's do definite integral. Let's practice. Let's say I have this function f of x again equals 4x minus x squared. And I want to find, if I graph that, it will look like this. I want to do it from 0 to 4. From 0 to 4, the graph will look like this. This is the 0 and that's the 4. And I want to find that area. So the area is going to be what? The integral from where to where? From 0 to 4 of 4x minus x squared dx. Now, last class, again, we discussed some of the properties of integrations. If you see a problem like this and it's too big for you to handle, break it down from 0 to 4 and do the first one, the 4x. Since the 4 is a constant, I'll take it, put it in the front. Minus the integral from 0 to 4. So you can break it down to two problems. If you've done a lot of these, you can do it as one problem. You don't have to break it down. So now, this is x to the power of 1. You're always going to add 1 to the power and divide by the new power. This one, I'm going to add 1 to the power, divide by the new power. And now let me put my x value from 0 to 4. So this is 2x squared minus x cubed over 3 from 0 to 4. So let's find the value at 4 minus the value at 0. Notice I didn't put a c there, knowing the c is going to cancel out. What is f of 4? When x is 4, plug it in. What's 4 squared? 16 times 2? 32 minus. That's 64 over 3. Minus what? F of 0. 0 minus 0, which is 0. If you need to add or subtract, you need a common denominator. That's 96 over 3 minus 64 over 3. You end up with 32 over 3, which is what? 10.666 if you want to round it. Actually, one way to see if this is really what I'm telling you is the exact answer or not, watch this, we'll give you a straight line. What is the integral from, I don't know, 0 to 3 of x plus 2 dx? Again, that's find the area under the function y equals x plus 2. What does x plus 2 looks like? It has a y-intercept of 2, a slope of 1. And I want to find the area from 0 to 3. Let's say 3 is here. Now, I could do this without integration, because you can break it down to two parts. That's one part right here. And what's the area of this one? What's the area of that piece? 6. 3 times 2. plus, and let me find the area of this triangle. If I know what the base here, I know what the height. This distance 3, if I know what that base is, I know this value here is 2. Do I know what the height there is? When x is 3, what's the y value? 3 plus 2? The height is 5. So my base for this triangle is what? Isn't that 3? 5 minus 2. So it's the base times the height divided by 2. The base is 3. The height is 3 divided by 2. That's 6 plus 9 over 2, which is 4.5. That's 10 and 1/2, or 10.5. I just took it, cut into 2 pieces. This graph here is y equals x plus 2. Now, if I integrate that, if I don't use geometry here, if I integrate that, here's my answer. Let's see if it gives me the same answer. What is the integral of x? That's x to the 1. What do? We add 1 to the power, and we divide by the new power. What is the integral of any constant? Nope, that's the derivative constant, 0. The integral? The constant times x. 2x. And you go from 0 to 3. Let's see if the answer from this is going to be 10.5 or not. If it is, what do you know? We write. The integration gives you the area under the curve. When x is 3, what's 3 squared? 9 divided by 2. When x is 3, what's 2 times 3? 6 minus the 0. Oh, what do you know? Look at this, 6 plus 9 over 2. That's 10.5.
Professor, how did you go from 6 plus 3.3 over 2 equals to 6 plus 9 over 2?
3 times 3, not point. That's 3 times 3.
I'm trying to figure that out
Yep.
for like 10 minutes.
That's 3 times 3. That's the base times the height divided by 2. The area of this shape right here. I broke this into 2 shapes. I said this is 1. Let me find the area of that. And that's the triangle, base times height over 2. And the other piece, the other one, I looked at it as this piece. So I broke into 2 pieces. This one, rectangular shape, width times height. This is base times height over 2. And you add them, and there's your answer. So that's what I did. Now, where we might have a problem if we have like 2 functions, you're trying to find the area between them. Well, let me try a few examples with definite integral here. I'm trying to squeeze as much as I can with one class there, so. But let's do another integral problem. What is the area? Let's try this. From 3 to 3, pick a function, any function you want. X squared plus 5x dx.
Wouldn't that just be 0?
Yes. Why?
Because there would be No, it would only be one dimension.
Yep, it's one line. You can graph x squared plus 5x. I don't care what the graph looks like, but it's a parabola. So it might look like this. And I'm saying find the area as x goes from 3 to 3. Find the width of this line, or the area of that line. It does not have a width. But if you did your integration, you end up with what? X cubed over 3 plus, there's the 5. What's the integral of x? The integral, not the derivative. X squared over 2. You always add 1 to the power, divide by the new power. And you're going to go from 3 to 3. When x is 3 here, 27 divided by 3, which is 9, plus 5 times 9 is 45 over 2. Minus, when x is the lower limit, now when x is 3 in the bottom, that's also 9, and that's 45 over 2. You add, or you're subtracting the same thing. So your answer is always going to be what? 0. So that's one of the properties of definite integral. I don't care what the function is. If you're integrating from a to a, doesn't matter what the function is, of f of x dx, that answer is always going to be 0. Always. If these two are the same, the answer is always 0. Another property we can actually derive, and that's if you're integrating from a to b of f of x dx, that's going to equal to the opposite if you go from b to a, if you flip them when you have a definite integral. So if you flip the limits, your answer is going to be backward. And you can test it in any function. I can just take a simple problem, nothing fancy, like this. From 2 to 3 of x squared dx. Integrate that, and integrate from 3 to 2 x squared dx. And see if the answer from this opposite to the answer from this. Because I switch the limits. According to this rule, my answer should be backward to that. Well, let's see. Integrate that, that'll be what? X cubed over 3. From 2 to 3. Here's the minus sign. This will be what? X cubed over 3 from 3 to 2. Let's see what this one is giving me. When x is 3, that's what? 27 over 3, which is 9, minus, when x is 2, that's 8 over 3. Is that 19 over 3? Here's the minus sign. Let's integrate this one. When x is 2, that's what? 8 over 3, minus when x is 3, which is what? 27 over 3. Isn't that negative 19 over 3? What's a minus minus? Positive 19 over 3. So be careful. If you switch the limits, your sign is going to be, if you switch at the upper and lower limit, your answer is going to be the opposite to the correct answer. So be careful what you write there for limits. It's not the same answer. The other one I write here, if you want to integrate, I'll put this rule up there, from a to c, f of x dx. Sometimes you have two functions to use there. You can break it down from a to b, f of x dx, plus from b to c of f of x dx. That rule is available there too. If you want to integrate from a, just like you want to take a bus from Springfield, let's say, from Boston to Washington, D.C., nothing is available. So you want to go from Boston to Washington, D.C. Taking a bus here. That's my integration. We go to the bus station and say, sorry, I don't have any bus that goes to Washington, D.C. No problem. I can go from Boston to where? To New York. Then go from New York to Washington, D.C. So that's really what we're doing. We're saying, okay, I want to integrate from A to C, but maybe my function changes. So I can go from A to B, change bus there, change the function, and go from B to C. Now, where are you going to use that? If you have a function that looks like this, a piecewise function, f of x equals x squared for x less than 3, and 2x minus 5, well, when x is 3, that's what, 9? You have a function that looks like this. Again, if I graph that, unless I want to find the area from, I don't know, 2 to 5. Here's what my graph looks like. All the way to 3, it's like this. There's the 3. At 3 now, it goes like this. Straight line, two different functions. And I want to find the area as x goes from 2 to 5. It's not the same function. I cannot do that in one step. So if they say, what's the integral from 2 to 5, f of x dx? I go, wait a minute, I got two functions. I got to break it down. I can find the area from 2 to 3 of x squared dx, add to it from 3 to 5, 2x plus 3 dx. So basically what I'm doing, I'm finding the area, because they're two different functions. Find this area first, find that answer, and add to it this answer. If I take both of these, add them, I have my answer. And so that's why you want to break it down, in case you're wondering why. So if I integrate that, that's x cubed over 3 for the first one, from 2 to 3, add to it. Let's integrate that. The power of x is 1. Add 1 to the power. X squared over 2. And the integral of any constant is the constant times x, as x goes from 3 to 5. The 2's cancel each other out. So that will give me what? 9 minus 8 over 3 plus, the 2's cancel, 25 plus 3 times 5, 15, minus, when x is 3, that will be 9 plus 9. the value of this at 5 minus the value of this at 3. So this is the first one. This is the second one. Remember, the 9 is what? 27 over 3? So 27 minus 8, which is what? 27 minus 8, is that 19? That's the answer to this. 25 and 15 is what? Is that 60? Or not 60? 40, I mean. 40 minus 18. What's 40 minus 18? 22? Positive 22, right? So if you want to add them now, your common denominator is 3. That's 66 over 3. $85 over 3, is it? Or 75? 85? Yeah. 85 over 3. That's the area. Now let me give you just one little problem and see if you can think about it. How are we going to get the answer to it? Let's say I have this shape here. And this is x squared plus 1. And this one, the second one I'm going to graph here, this is 4 minus x squared. And let's say I want to calculate this area right there between them. How will figure out the area between them? Picture-wise, if I was to graph that using pictures here, I don't know where they cross each other here. I got to figure out what that value is. Now, I didn't think about this. I might regret this problem now. Let me just think just briefly about this to make the numbers look nicer. How about a 5 instead of 4? There's a reason why I chose the 5 instead of the 4. I wasn't thinking first. But if I do this one, the one 5 minus x squared, and I calculate, I can find out, by the way, what that value is. How do we figure out what that value is? What is that x value? Any idea? How do you figure where they cross each other? Set them equal to each other, absolutely. Now, if you move the x's to one side, you'll have 2x squared equals what? I don't really do a good job. I thought I planned it right. Nope. I should have made that a 9. One more adjustment. Let's make it a 9. Try to make the math a little bit easier. A 9, not a 5 here. You'll see why I chose a 9 now instead of the 5. So if I do a 9 here, What's 9 minus 1? 8. So what do you do now? You take this and divide it by 2. You have x squared equals what? 4. X equals plus or minus 2. They cross each other at 2 and at negative 2. I don't care about the left side. I'm only interested in the right side because I'm looking for the area from 0 to 2. So if I find the 2 here and I integrate just this one, if I integrate that, I'm going to find all this area, all of it. Well, that's not the correct answer. That area is all of this, all the way to here. But if I subtract from it, if I take away from it, let me draw that picture so you get to see it. This is the 2. And if I subtract from it this area now, I'll end up with what I'm looking for. So the first one, if I look at that picture, gives me this area. That's what the first one's given me. I'm going, oh, wait a minute, that's too much. You can see that's too much. You can see that, right? Let's subtract from it this area. Let's take away from it that one. What would you have? Isn't that the area that you're looking for? So if you take the first piece, subtract from it the second piece, wait a minute, isn't the area the integral here from 0 to 2 of that function? So this is going to be the integral from 0 to 2 of the top function minus the bottom function. My top function here is what? My top one is 9 minus x squared. Minus my bottom function, which is what? X squared plus 1. If we clean that, you will have the integral from where to where? From 0 to 2. 9 minus 1, which is 8, minus what? 2 x squared dx. Let's finish that one. Let's integrate it. That would be 8x minus, here's the 2, add 1 to the power, divide by the new power. From 0 to 2. Eight times 2, 16 minus 8 times 2, that's 16 over 3, minus the value at 0, which is 0. And I think that's, you multiply by 3, that's 48 over 3, minus 16 over 3, and my answer is 32 over 3. So the area between them is 32 over 3, or 10 and 2/3.